In example 2, we did a complete analysis of our function via the first and second derivative tests, and we then compared our analysis to a graph from a calculator. But in example 3, we are actually going to sketch a curve based on some information. And so again, this is not going to be the exact function. We don't know what the function is. They haven't told me the function. They've just given me a bunch of results regarding the first and second derivative, and we're going to see what we can do in terms of creating a sketch of a curve that will satisfy these requirements. So the first thing that I want to do is to lay in some number lines for sign charts for both f prime and f double prime. So let's do that. All right, now let's take a look at what they have told us. So they say that f prime is positive on the interval from -∞ to -3, and also on the interval from 1 to 4. So let me mark out those critical values. So -3, 1, and 4, and this is for f prime. So we know that f prime is positive on the interval from -∞ to -3. So we'll put a plus right here. And we also know it's positive from 1 to 4, so we put a plus right here, and that takes care of our first condition. They tell us that f prime is negative on -3, 1, and 4 infinity, so we'll put in minus signs on our sign table or sign chart. All right, on to, let's drop on down to E here. They say f prime of -3 is equal to f prime of 4 is equal to 0. So that means that these values right here are going to be extrema because the slope is equal to 0. That's what they're saying. The slope, f prime, is equal to 0 for these values. And you know what? Looking at this, I think that it makes sense. Since the slope is changing from positive to negative, does that mean that it will be a maximum or a minimum at -3? Maybe it would help if we went ahead and made inferences about increasing and decreasing. So f prime is increasing when the slope is positive, decreasing when the slope is negative, so that means that -3 is going to be a max. All right, now for 4, increasing and decreasing. And that means, again, that we are going to have a max. Now, they have given us a lot of information about f double prime, so let's put this in. So they tell us that f double prime is negative on -∞ to -1 and 2 to infinity. And so I can see that my critical values for f double prime are going to be -1 and 2. So let's put those values in. All right. And so f double prime is negative on -∞ to -1. So let's indicate that as negative. And this is also going to be negative from 2 to infinity. They tell me f double prime is positive on the interval from -1 to 2. And so we know that for the original function, that tells us about the concavity. So negative means concave down, positive means concave up, negative is concave down. Now lastly, they tell me that I have f double prime equal to 0 at 2 particular points, -1, 3, and 2, 4. And so that means that these are going to be points of inflection. So P, O, I, O, I. And I'm like, you know what? You didn't even have to tell me that, because I can see that the concavity is changing from concave down to concave up. So of course -1 is a point of inflection. Here we're going from concave up to concave down. So anytime that concavity changes, it means that point in between is going to be a point of inflection. Okay, actually I'm glad they gave me this, because they didn't tell me what the function was and I wouldn't be able to substitute in to find the y values. So they did do me a favor. They told me what those points are. We've got everything we need to not graph the function, sketch the curve. So let's do this. Let's start by putting in these special points and labeling them so we know what they are. So -3, we have a max, and you know, I have no idea what the corresponding y value is. I'm just going to make up something, but that is going to be a relative max. I have another relative max at 4. 1, 2, 3, 4 again. Just going to make up something. Now our points of inflection, we know exactly where those are. -1, 3, and +2, 4. All right, now from -3 to 1, my function is has negative slope. It's decreasing. So you know what I just figured out? I didn't put this point high enough. So let me raise that one up a little bit. So we'll just put it up here somewhere. And let me look at this next point of inflection. This is at 2, and we're going from concave down to concave. I'm sorry, from concave up to concave down. Let's see. If we look at 4 on my f prime graph, I can see that the slope is positive to the left. That means the function is increasing. And I'm not increasing from that point of inflection to the max. You know what that means? I didn't put this one high enough either. So that's okay. We can change it. Put it up there. All right. Now all I need to do is just kind of sketch a curve that will make my function increase on the interval from -infinity to -3 at that max. All right. So how about something like this? So from -infinity to this max, I'm increasing. And now I'm going to decrease, and I'm going to decrease down to this point of inflection. Now I'm going to increase to this point of inflection. We go from concave down to concave up. You know what? Let me make this a little bit more clear. I'm concerned about my concavity. So this is a point of inflection right here. So that means that it goes from concave down to concave up, and I want to really show that. So let me let this continue down to here, and then now it's very clear that my concavity is changing. Let me round this out a little bit more. And now my function is decreasing again. And that gives me a pretty good sketch of what a possible function might look like that would satisfy these criteria. I mean, it's not perfect, it's not a graph, and as you can see, there was a little bit of trial and error as I laid in points. Maybe a good guideline is to do your points of inflection first, look at concavity, and look at increasing, decreasing on either side of those points of inflection. But then, even if you put the max or mins in a wrong place, you can always move them. It's no big deal. So you just put one piece of the puzzle in at a time, and you've got something that satisfies all of these criteria.